All right, good afternoon or evening, everyone. Let's do this next video, lesson 218. What if both sides are equal? Using algebra tiles to solve for x. Now, again, this is one of the final lessons of this chapter, and so we're really putting things together. This is not the easiest thing to do, so please make sure you pay close attention as we work through these, okay? Can you always tell whether one algebraic expression is greater than another? In this section, you will continue to practice the different simplification strategies you have learned so far to compare two expressions and see which one is greater. However, sometimes you do not have enough information about the expressions. When both sides of an equation are equal, you can learn even more about x. As you work today, focus on these questions. How can you simplify it? And we've been working on that. Okay? How can you get x alone? Is there more than one way to simplify? And is there always a solution? So those four questions are going to guide our discussion today here, okay? Problem 273, please write down 273, okay? What if both sides are equal? If the number 5 is compared to number 7, then it is clear that 7 is greater, right? Makes sense. However, what if you compare x with 7? In this case, x could be smaller, larger, or even equal to 7. Examine the expression comparison map below. This one right here, see it? Okay. On the left-hand side, we've got an x. On the right-hand side, we have 5. Okay. So the question is, question A. If the left expression is smaller than the right expression, what does that tell you about the value of x? If this is smaller than this, what must be true about x? Take a second, think about it, write it down, and then when you're done, unpause the video and see if we agree. All right, and again, I'm really hoping, I know I'm not at your house, and I don't want to be, that's your private place, but did you pause the video? Are you pausing it? Are you really trying these, or are you just kind of letting it go and you kind of sit back and let things happen? If you are just letting things happen, guys, you're not learning, so please, 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 always try these problems, okay? So if the left side is smaller than the right side, what does that tell you about the value of x? That means x has to be less than 5. Because if it would, well, yeah, anything less than 5 is going to make this smaller than that. Okay, so what if the left expression is greater than the right expression? What does that tell you about the value of x? If the side is bigger now, what must x be? And this one I think you can probably figure out. X must be greater than 5. And what if the left expression is equal to the right expression? What does x have to be for the two expressions to be equal? Well, x must be equal to 5. Now, you look at these questions and you're like, well, this is really stupid, really obvious, Mr. Ramirez. I know, it is, that's fine. But we need to set that up as we prepare for this problem now. Now, this problem is a challenging one here. 274, solving for x. In later courses, you will learn more about situations like part A and B in the preceding problems called inequalities. For now, to learn more about x, assume that the left expression and the right expression are equal. So back here we did talk about these inequalities, greater than or less than, but today we're just going to focus on what if they were equal to, okay? And in fact, throughout this chapter and year, we're going to talk to them as is most of the cases if they're equal to each other. The two expressions will be brought together on one map to create an equation mat, as shown in the figure, right, which I'll show you in just a second here. The double line down the center of the equation mat represents the word equal. It is the wall that separates the left side of the equation from the right side of the equation. And here's the equation mat that we're talking about. See this double line right here? So that double line means equal, and it means this side is going to be equal to this side over here. Okay? That's what we're going to be working with as we're trying to do these parts and do that. Okay? So build the equation represented in the equation mat at right using algebra tiles. Simplify as much as possible and then solve for x. Be sure to record your work. We got to focus on that. So actually, I do have it right here. You're going to work with me on it. Maybe let's see if it comes up over here. So here it is. Okay. So let's work on this problem together. Oh, where did it go? Come on. It's not showing up. Hold on a second. Let me bring it over. It just snuck off to the other side. And if you were at home and wanted to, you could click on this and do this as well. All right, so here we go. We are going to work on building this. So on your paper, this is 274. Please write this down. What do we have? I have x plus 1. Oh, actually, you know what? I'm going to stop right there. Will you do me a favor? Will you please write what we have on there? And let's see if we agree. So again, pause the video. Please, guys, this is great practice. You really need to know how to do this. This is a great way to check if you're understanding. Pause it. Do it. When you're done, just write out what's here, okay? When you're done writing that out, unpause it and follow along with me here. Okay, let's see if you were right. So we had x plus 1 plus negative 2 minus parentheses, and we got this right here, 1 plus negative 2x. Well, that's written horribly. I'm sorry. Let me see if I can fix that. 2 minus parentheses 1 plus negative 2x. Then I'm going to bring this equal sign down. Okay, that means equal. Over here I have 5 minus parentheses negative x plus 1. That is the first step. Okay, that's the original equation. And so we're going to write down original equation. I'm out of room there, so I'll just put original EQ. Step number 1. Step number 1 is, as we have mentioned several times, probably the best thing to do is flip it. So we're going to flip the values up here. So that means this stays the same, x plus 1 plus negative 2. However, this 1 goes to the opposite, which would make it negative 1, or plus negative 1. Okay? And let's go ahead and do that. And then these two negative x's flip up here, and they become their opposite. So plus, oh, hold on. Oh, that. Okay. Plus negative 1, and then plus 2x, because the opposite of negative x is 2x, equals. Okay? 5 stays the same. We are going to bring this one up here and make it its opposite, and bring that up there and make it the opposite. So, the opposite of negative x is positive x, and the opposite of positive 1 is negative 1. Okay? And we flipped our values. Write this down. I'm looking for this as your notes, okay? We flipped our values. Now, what can we do? Well, we've got two things we could do. We could do the balance set, or we can do zero pair. But I'm going to go ahead and do zero pair. I think zero pair is a good next step. It's also called combine like terms. Now, we can do several things here, ladies and gentlemen. You could look at the tiles and say, well, all these x's are the same. Oh, but look at this. These two right here are zero pair, right? So zero pair that out. You could also look down here and say, oh, look, combine like terms. I got 2x, or x and 2x. X plus 2x is 3x. See, I combine these, I've got 3x's. And 1 and negative 2 and negative 1. Well, doesn't this 1 and the negative 1 cancel out? And you're left with negative 2. Then, bring the equal sign down. And then over the left side, what do we have? Well, the only thing we really have are these two. I won't change. A positive and negative here, so we get rid of those. So, the x stays the same, but this 5 and negative 1, 5 plus negative 1 is negative 4. And so we combined like terms. Now, some teachers make you write out specifically what you did. I don't mind as long as you've got this. Okay? Now, next step. What do I have next? Balance sets, right? So balance sets, I've got, let me get rid of that. I've got this x and this x. I can get rid of an x from each side there because it maintains balance as long as you do the same thing. So that's going to get rid of this one and get rid of one of these three x's to where I'm left with 2x plus negative 2 equals negative 4. Okay? Not negative 4. What am I doing there? Oh, I didn't, sorry. I missed that mistake myself. So this would be, get rid of one of those and you would be left with, that'd be 4. Wow. Sometimes that happens, doesn't it? And you're left with 4. Okay? Now, at this point, what can we do? This is where it gets really challenging. What would I do at this point? Am I done? Is this as far as I can go? Okay? Well, if we remember, yesterday we did talk about some options about what to do in this situation. And what I think I have to do here is, remember that additive property? What if I add zeros to something, it doesn't change it? What if I add a couple zero pairs? And so what I'm going to do is I'm going to add a couple pairs of zeros. So here's a positive and a negative. And I'm going to add another pair of zeros, positive and a negative. Isn't that both zeros, right? So I'm adding a couple zeros there, and that looks kind of weird. But by adding a pair of zeros, now what can I do? These four did not change the value at all because they're just zeros, right? But now I can balance out the negatives because my goal is to get the x alone, to balance out the negatives. So what I did was I added two positives to both sides. And now I'm left with 2x equals 6. And then if 2x is 2, if these two have to equal these 6, that means each one of these must be equal to 3. So if I divide both of these sides by 2, I'm almost out of room here, divide by 2, I get my answer, which is x equals 3. And that is how I do this process. That is what we're aiming for. That's what we're trying to get to now, is to get to that place where we can kind of work these out algebraically and with tiles to where we get the x alone on one side equals a specific value, okay? If you need to watch this again, and right here, we did balance sets. If you need to watch this again, please pause this and watch this video again because this is really important that you understand this process, okay? We're going to do one more problem here, okay? And that problem is part B of this, and it says build the equation 2x minus 5 equals negative x plus 5x plus 2. You're going to build that equation, and then look, it even says 2x minus 5 on the left side and 1 plus negative 1 plus 5x plus 2 on the right side. Then use your simplification skills to simplify this equation as much as possible so that x is alone on one side of the equation. Use the fact that both sides are equal to solve for x and record your work. Okay? So I'm going to come back to here and I'm going to erase my writing here and we're going to do this one together. Now, again, I don't mind doing this together today. Tomorrow you'll have to do this problem on your own. Okay? So please make sure you're understanding. So I had 2x plus negative or minus 5. Oh, that's cool. I can just kind of 2x minus 5. There, 2x minus 5. On the right-hand side, I've got negative x plus 5x. So 1, 2, 3, 4, and 5. And then plus 2. So plus 1 and 2. So negative x plus 5x plus 2. All right, let's see if I'm right. So again, on this side, I should have 2x minus 5. Now, some of you are like, Mr. Ramirez, can't I just have these up here and make it plus negative 5? I could, because minus 5 is the same as plus negative. Equals, and then on the right-hand side, I've got negative 1 plus 5x plus 2. And again, this is my original equation. You do not have to draw this out, but you should be following along with me. And you do need to write this process below, these steps below. Okay? So here we go. Let's do the same thing. Let's simplify. Let's see how we do it. Okay? If you want to try this on your own, if you think you can do this problem on your own, please feel free to try it. Simplify it as much as you can and see what you end up with. When you're done, unpause it and we will go through it. Okay? All right. Here we go. So the first thing I'm going to do is, as many of you said, I want to flip these up. I want to get them all to the top, and of course they switch to the opposite, which really all that does is add the opposite. See that? See that? That's all we did. So 2x plus negative 5 equals negative 1 plus 5x plus 2. And that's we flipped. Positive, or yeah. We'll just say flipped, okay? Next step, let's combine like terms or zero pairs, okay? So zero pairs, can I combine anything on the left-hand side? Nope. So I just keep 2x plus negative 5 because they're not the same. Can I combine anything on the right-hand side or zero pair? Yes. Now, again, if you need to do the tiles, do the tiles. If you can do it focused on just the numbers down here, do the numbers. What's negative 1 plus 2? Negative 1 plus 2 is positive 1. So I'm left with 5x plus 1. And you can see this up here because if I take this positive and negative, they cancel out, you're left with that. Awesome. And that was combine like terms. CLT, combine like terms, or zero pair. Next, balance. We're going to balance things out here. An x and an x. Oh, and another x and another x. So get those out of the way. Okay, so what does that look like here? I took away 2 x's here. So 2 of these x's take away 2 of these x's here, and I'm left with 3x plus 1. All right, so I balanced out 2 x's. Next, my goal is to get the x alone. What side is the x on? The x is on the right-hand side up here. So I need to get everything that's not an x out of here. I need to get rid of one tile here. How can I get rid of a tile there? Well, I could either zero pair, but if I go here and add a zero pair, yes, this positive and negative cancel out, and I'm left with another one anyway. So that doesn't quite work. What if I zero pair, add a zero pair to this side here? Now can I do something? Yes, now I can balance out this. So by adding 0, it allows me, I added a negative to both sides, so it's like I took that away, all right? So I end up with a -1 here and -1. 1 and negative 1 cancel out. I'm left with -6 equals 3x, okay? And then, if 3 of those x's equal -6, if I divided both sides by 3, and I'm out of room here, so I'm gonna have to cram it up here. -6 equals 3x, then each of those x's, 3 over 3 cancels out, and I do 6, -6 divided by 3 is -2. So my answer would be x equals -2. Does that make sense? I hope so, okay? We're gonna practice some more of the skills tomorrow. That is it for today. Thank you for watching. Hopefully you've got all those notes, and we will finish tomorrow.